Hello, Professor Balaji. This is Venkatreddy Gabi. Myself, along with Sai Krishna Bora, Venkatesh Pusarla, and Manohar Malineni, represent Group 13. We shall be presenting on our final project, Sentiment Analysis on Twitter Data using Statistical Text Mining. For this, we shall make use of Rapid Miner to build and evaluate models. The process includes loading the data, processing the data, generating term by document matrix, building models, and finally applying the model on new data to predict the outcome. We also created a process diagram for similarity-based methods and clustering techniques for measuring the similarity between documents. Now Venkatesh Pusarla will continue explaining about the pre-processing of data.
This is our training data. We have two attributes over here. One is tweet and the other one is sentiment. We have captured about 7,000 tweets from the Twitter, and we have manually given whether the tweet is either positive or negative from the words in the tweet. Words like love suggest that it is a positive comment, and words like broke or hate suggest that it is a negative comment. This data we'll be using to train the model, and then from that model we'll be giving a different data set which has no target variable, that is a sentiment variable, and we will be applying the model on that data to determine whether this tweet is either positive or negative. We have already designed the process diagram for our analysis using the Rapid Miner tool. In order to input the raw data, we are using the read Excel operator. Here we can import the Excel sheet. Now we have a data which is not clean. So in order to clean the data and remove any unwanted terms, we are using the process document operator. We have some steps over here which will be cleaning the input data. The first operator we'll be using is the transform cases operator. Here the entire document is transferred into the lowercase letters. Next, we'll be using the tokenize operator. This operator is used to split the text into sequence of tokens. The mode which we'll be using over here is non-letters, like if we have a space or a full stop, the word will be split over there. I mean, the string will be split into words over there. Next, we'll be using the filter operator. This is used to remove any unwanted words, like the common words which we use in English, such as is, the, are, has, etc. Next, we'll be using the filter token operator. This will be used to remove tokens based on the length, like words which have minimum characters of 3 or less will be removed, and words which are having characters more than 20 will be removed over here. The fifth step is the stem potter operator. Here we'll be using the potter stem algorithm on our input data to reduce any word to its base form, like the words such as taken, take, took will be converted to the base form, which is take. We are done with the pre-processing steps. Now for all the tweets in the dataset, a document by term matrix will be generated. We can see the document by term matrix over here. Here we can see that documents as rows and terms as columns. Now, and also we can observe that a TF-IDF score are assigned to each term across all the documents. Now, here TF-IDF shows how important a word is to a document in whole corpus. Hence, it is mainly used as a weighing factor in text mining scenarios. Here TF stands for term frequency. It gives the frequency of terms in a particular document, and IDF stands for inverse document frequency. It shows how informative a term is across all the documents. Here the TF-IDF score for the term accept is 0.456 in the document 268, and for the term abort it is 0.319 in the document 271. Here these zeros indicate that these terms are not present in these documents. The output of the process document operator is given to the setRoll operator. We are using the setRoll operator in order to make the system identify sentiment as the target variable. Here we are giving the attribute name as sentiment and the target role as label. Here we are setting the sentiment as the target variable. Now the select attribute operator is used to filter out any attributes which have any missing values. Here the filter type will be no missing values. This filters out any attributes which have any missing values.
Hello Professor, this is Sai Krishna. I will be continuing from here. The output of the select attribute operator is given to the split validation operator. Here we are dividing the entire dataset into training and test datasets. We are giving the split ratio as 0.66, which means that 2/3 of the data will be used for training and the remaining 1/3 is used for testing the model. If I double click on the validation operator, we can see that we are building a decision tree using the decision tree operator. The training data is given as input to the operator and the operator will generate the model. The apply model operator is used to apply the model on the testing data set, and we are using a performance operator to measure the performance of the model that is built. Now I am going to run the model and view the results. As you can see here, this is the decision tree that is built by the operator. Based on the input training data, all the negative words such as suck, hate, stupid are identified and the tweet classification is done accordingly. If we go to a different view, we can see that for the word suck, if the TF-IDF score is greater than 0.031, then the tweet is classified as negative, and if it is less than or equal to 0.031, then the tweet is classified as positive. Similarly, the classification is done for the remaining negative words as well. If any tweet doesn't contain any of these negative words, then the tweet will be classified as positive. Now if we click on the performance vector tab, we can see that the accuracy and the confusion matrix. For the model that is built, we can see that the accuracy is 99% and 1364 tweets that are actually positive are predicted as positive and 19 tweets which are actually negative are predicted as positive. Similarly, 5 tweets which are actually positive are predicted as negative and 1021 tweets which are actually negative are predicted as negative. We have built two more models. One is the naive Bayes, the other one is the support vector machines, and the results are noted down for evaluation. These are the accuracies for various models on different splits. We can observe that all the models are nearly the same in terms of accuracies. However, we can conclude that decision trees gives relatively better performance when compared to other models, and naive Bayes gives less performance of the three.
Hi Professor, this is Manohar. I will be explaining how we can apply this model on new dataset for classifying the tweets whether they are positive or negative. This new dataset contains around 33,000 tweets. We have selected decision tree model as it is having relatively better performance compared to other models. The validation operator will give the decision tree model as the output, and we are using the apply model operator to apply this model on the new dataset. Before applying the model, the new dataset needs to be processed and document by term matrix needs to be generated. We will be following the same data pre-processing steps like transforming, tokenization, filtering, and stemming for the new dataset too. We will run the model and view the results. Here we can see the processed text along with the prediction values. For each prediction, we can also observe the corresponding confidence levels. For example, tweet like Love Seattle is classified as positive with a confidence level of 0.991, and the tweet Lakers sucks is classified as negative as it contains the negative word suck. Till now, we have seen how text mining can be used for sentiment analysis. Now, we would like to show how text mining can be used for finding the similarity between the documents and categorizing them into clusters based on their similarity. The documents are stored as rows in an Excel sheet, and we are feeding this Excel sheet to the process document operator. As we have observed previously, we are performing the same data pre-processing steps like transforming, tokenization, filtering, and stemming for the new dataset too. We are also generating n-grams of size 3 for better accuracy. The output of this operator, which is term by document matrix, is given as inputs for clustering and similarity operators. Similarity operator performs cosine similarity on this matrix, and we are using k-means clustering for categorizing the documents. The number of clusters is set to 10 and max runs is set to 40 in this k-means clustering. Now we will click on run and view the results. This is the output of the similarity operator. We can see that doc 1 and doc 8 are having the similarity 0, which means that they don't have any common terms. Doc 1 and doc 15 are having the similarity of 0.95, which means that they are almost the same. As we can see in the input file, doc 1 and doc 15 are having the same text. Now, if we click on the cluster model tab and go to folder view, we can see the documents getting categorized into clusters. If we click on cluster 0, we can see all the similar documents here. For example, doc1 and doc15, which are having similarity measure of 0.95, are clustered together here. So, in this video, we have seen how text mining can be used for sentiment analysis and document classification. Thank you.